So let's go into the README file and find the next command we need to enter, which is erasing the cache. Okay, so we're starting to run that, and that's going to take a while. In the meantime, I'll point out that you can see that in the background there I have the EasyCap input streaming into MPlayer, so we can see the device's output. And right now, since we're in fast boot, there is no video output, so it's just a blue screen, but when the device does come up, we'll be able to see the screen there. So this will take a while. We're going to get a cup of coffee, and then we'll go on to the next step. Okay, so that finished. Go on to the next step. This one goes pretty fast. Okay, and then the last one. This will put the system image on, which is pretty big, so it's going to take a while, and then when it's done, it's going to automatically reboot the device. So again, this will take a few minutes, so just sit tight. Okay, so now it's done writing. We can see that the device is rebooted. Okay, there's the kernel is booting. Okay, and the device is finally coming up. And when you're first starting it up, it's going to take a lot longer to come up than when you come back later and just restart the device. The first time through, definitely, there's a lot of initialization that'll take extra time. Okay, signs of life. And there we are. We're up. So let's see what we got. Okay. So let's go into settings. And look at the about. And there we have it. Android 4321. Very good. I'm not going to bother doing it now, but you might want to, the first thing you probably want to do is go into the display and set the timeout time to like 30 seconds or something, or sorry, 30 minutes. So now we can see that the Wi-Fi is working. We're detecting all kinds of networks. Other things in settings, everything looks good. Bring up a simple app. That works. Okay, so this is a perfectly good version of Android. You can sideload apps onto it and do all kinds of stuff, but there is actually a problem. If we go down and we look at the accounts manager, we'll see that there is no account manager for Gmail. Now this is a problem because there's a lot of services that rely on having your Gmail account set up, and we can't do that. One of those services is in fact the Play Store, and you can see that the Play Store isn't installed either. Now the problem here is that there's a whole bunch of proprietary binaries that are not part of the open source tree, so they did not come down and they're not part of this build. So let's review where we are. We have a perfectly good distribution of Android, but we're not getting the full Android experience because there are certain binary APKs that Google has that did not come down in the Android source tree. So they're not on our Pandaboard. So we'd like to get those APKs and install them. Now, this part is purely optional. You may not want to go through the effort. You may not want to run your Pandaboard with these Google services installed anyway, but just to go through the procedure shows how we can modify and update some of the system images and reflash them and modify our device any way we want. So the question is, where are we going to get the binary APKs that we need? Well, it turns out there is no Pandaboard distribution from Cyanogen, but they do have a package that we need. So if we just go on the web and search for Android G apps, turns out they have several versions. I've been using the one from August 13th. You may experiment with the others, but this one works pretty well. You simply follow the link, download. It's going to be a zip file. I'm not going to download it because it takes a few minutes, and I've already got it downloaded, but that's where you would go to find it. So before we start messing around with stuff, let's see what we got. Now, when we did the build, we created this out directory. So all the binary stuff that we created got built into the out directory. So in there's a host and a target. The host is the stuff that we use on the host machine, obviously, and if we go into the bin, we see some familiars like ADB and some other SDK tools. We'll be using some of these in a minute. On the other side, we have the target, which is the code that's obviously going to go on the device. And if we go down to here, we see this is basically the object code for the Pandaboard. It's really combined in these files. Now, it turns out that the one we want to modify is the system image. So let's describe how we can get that. The system image is basically a compressed ext4 file system. So we can uncompress it and then mount it, modify it, recompact it, and flash it over to the device, which is basically what we're going to do. So to start with, I'm going to create a temp directory because I don't want to mess around with anything that's in the actual object directory. And then I'm going to use this tool, S-image to image. It takes the image that you want to open and a file name that you want to create the new file system in. So I just do that. This is in the host bin directory that we were just looking at a minute ago. And we do that. So now we have the system raw, and now we can use the mount loop device to mount that file system. But before we do that, I have to create a mount point called sys. And then I simply do that. So now, if we look at our mount table, we can see we now have a new file system that's mounted at our mount point. So we can go in there, and essentially what we're looking at is everything that's going to be on Pandaboard under the sys directory. So if we go over to our Pandaboard that's still running, we can go to System, and essentially what we have here is all the directories that we see that we just mounted on our host machine. So at this point it would make sense to just copy stuff into this file system, but the problem is, you can see it's already at 74% full. There's not a lot of spare space there. So what we're going to do is copy it from that file system onto the hard disk, and then we'll modify the hard disk version. So let's just do that. So we're going to copy sys into system, and we have to do it as root, and we want to do it recursively. We want to follow symbolic links, and we need to preserve all things like the user ID bit. So we have to use the RLP parameters. So we do that, and first I have to move up. Okay, so now we have a mirror image in system that was in sys. So now I'm going to go ahead and unmount the loop device. We don't need that anymore. So if we check this out, now we see it's no longer there. And now we're ready to unpackage the gapps package. So I'm just going to run as root the unzip tool. Here's my gapps file, which I download in my download directory, and it does a bunch of stuff. And now there's some stuff that's potentially going to be replaced, so I'm just going to say go ahead and replace everything, and boom. So now we have an updated version. So now I want to repackage that thing. And I'm going to use the make ext for file system tool that again is in the host directory, in the out directory. And we're telling it we're making the file system of system type. We're going to copy it as name system.image.new, and we're going to pick up what we want from the directory called system. So now we have a system image new that is the new version of system image.